Ever wondered why we don't float off into space? Gravity is the invisible force that keeps us grounded. It's a fundamental aspect of our everyday lives, so integral that we hardly notice its effects. From the moment we take our first step as a toddler to the time we toss a ball in a park, gravity is at play. It's the unseen puppeteer that ensures everything falls back to Earth. It binds us to our planet, shaping our physical reality. But what if we peel back the layers of this unseen force? What is gravity exactly? It's a natural phenomenon by which all things with mass or energy, including planets, stars, galaxies, and even light, are brought toward each other. This gravitational pull is what keeps the Earth orbiting the Sun and the Moon orbiting the Earth. What if we told you that there are ways to seemingly defy this force? Intrigued? Keep watching. Remember Galileo's famous experiment from the Leaning Tower of Pisa? Let's revisit it with a twist. Imagine standing atop that iconic Leaning Tower, a feather in one hand and a lump of lead in the other. According to our everyday experiences, the lead should plummet to the ground far faster than the feather. But what if I told you that's not the case? Let's delve into a principle that Galileo postulated centuries ago, the principle of equivalence. This theory suggests that all objects, irrespective of their mass or composition, fall at the same rate under the influence of gravity. Intriguing, isn't it? Now imagine, if you will, a world where the air doesn't interfere with our experiment. In this world, the feather and the lump of lead are released from the top of the tower simultaneously. What do you think happens? They hit the ground at the same time. In the absence of air resistance, gravity pulls on both the feather and the lead with equal fervor, causing them to accelerate and fall at the same rate. This principle of equivalence, an essential cornerstone of Einstein's theory of general relativity, challenges our everyday experiences and perceptions. But what makes this principle so interesting? It's the fact that gravity doesn't discriminate. It treats a speck of dust the same way it treats a colossal skyscraper. The weight of an object doesn't affect how gravity influences its motion. This concept is not only fascinating but also fundamental in understanding how our universe works, from the fall of an apple to the orbit of the planets. So it seems like gravity treats all objects equally, but what if we could trick it? Have you ever played with magnets? They can show us a fascinating side of gravity. Magnets, you see, have this incredible ability to attract and repel objects. It's a force that we can easily observe and manipulate, but it's also a force that can defy gravity. Let's consider an experiment with a magnet and a small metallic object like a paperclip. First, you hold the magnet above the paperclip without touching it. There's a moment of suspense, and then the paperclip leaps from the table and clings to the magnet. What just happened? The magnetic force from the magnet overpowered the force of gravity, pulling the paperclip downwards, causing it to hover in mid-air for that split second before it snapped to the magnet. This experiment is a vivid demonstration of how different forces interact in our world. Gravity, as we know, is a force that pulls objects towards the center of the Earth. It's a constant, unyielding force that influences everything around us. But it's not the only force at play. The magnetic force, for instance, can either attract or repel objects based on their magnetic properties. And as we've just seen, it can be strong enough to overcome the pull of gravity. The paperclip, caught between the downward pull of gravity and the upward pull of the magnet, chooses to follow the stronger force. In this case, that's the magnet. What's really happening here is a tug-of-war between gravity and magnetism, and sometimes gravity doesn't win. This doesn't mean gravity has been nullified or switched off. It's just that another force has temporarily stolen the spotlight. So, as we delve deeper into understanding the forces that govern our world, it's clear that gravity isn't always the star of the show. Other forces, like magnetism, can step in and change the rules of the game. So we've seen that other forces can compete with gravity, but can we create a situation where gravity seems to disappear completely? Ever wondered what happens to water in zero gravity? Let's explore. Picture a simple droplet of water. Now imagine we're going to try and simulate a zero-gravity environment right here on Earth. Sounds impossible, right? But with a bit of ingenuity and a speaker, we can get pretty close. How, you ask? Well, it all starts with a droplet of water and a speaker. Yes, you heard right, a speaker, but this isn't your run-of-the-mill party speaker. This is a speaker specially tuned to create vibrations at specific frequencies. Frequencies that can affect how a droplet of water behaves. So we take this droplet of water and carefully place it on our speaker. The speaker is then set to vibrate at a frequency that matches the natural frequency of the water droplet. This causes the droplet to vibrate in unison with the speaker, creating what we call a standing wave within the droplet. But here's where it gets really interesting. As the standing wave forms, the droplet appears to float, to defy gravity. It's not actually floating, of course. It's held aloft by the vibrations from the speaker, but to the naked eye, it's as if gravity has taken a back seat. So what's going on here? Why does the water droplet appear to defy gravity? It's all about balance. The upward force of the vibrations is precisely balanced by the downward pull of gravity. This delicate balance creates a zero-gravity environment for our water droplet, allowing it to float in mid-air. Creating a zero-gravity environment on Earth is no easy feat, but with a bit of creativity and some scientific know-how, we can get a glimpse of what life might be like in a world without gravity. And that, my friends, is the power and beauty of science. It's fascinating to see water defy gravity, isn't it? But can we make an object completely ignore the pull of gravity? Have you ever seen a gyroscope in action? They can do some gravity-defying tricks. First, let's set the stage. Imagine a gyroscope, a spinning wheel or disc where the axis of rotation is free to take any orientation. This orientation changes in response to an external torque, much differently than you'd expect. Rather than falling over as a stationary object would, a spinning gyroscope moves in a way that seems to laugh in the face of gravity. How does this happen? Well, it all comes down to the principle of conservation of angular momentum. Just as an ice skater spins faster when they pull their arms in, a gyroscope's spin also causes it to react differently to external forces. Let's dive a little deeper. Angular momentum is a measure of an object's rotation around a specific axis. When an object is spinning, like our gyroscope, it has angular momentum. This momentum wants to stay constant, it doesn't like change. So when an external force, like gravity, tries to pull the gyroscope down, the gyroscope resists. But it doesn't resist in the way you might think. Instead of fighting back directly against the force and staying upright, the gyroscope does something a little more clever. It moves at a right angle to the force applied. This is known as precession. So, instead of toppling over, the gyroscope ends up spinning around in a circle. It's a nifty little trick that makes it look like the gyroscope is defying gravity. This principle isn't just for show, though. It's the same concept that keeps bicycles upright when they're moving and helps to stabilize satellites and spacecraft in orbit. Without the principle of conservation of angular momentum, our world would be a much different place. So, we've seen that with a little bit of physics, we can make objects appear to defy gravity. We've seen some fascinating experiments today, haven't we? We began our journey with the historical significance of the Leaning Tower of Pisa experiment, showing us that gravity is inescapable, pulling everything down at the same rate, regardless of mass. Then we dived into the mesmerizing world of magnets, witnessing how they can hover in defiance of gravity thanks to magnetic repulsion. We moved on to the intriguing zero-gravity water drop, demonstrating that in the absence of gravity, surface tension takes over, shaping water into a perfect sphere. And finally, we spun into the realm of gyroscopes, showcasing how their rapid rotation can resist gravity's pull, allowing them to balance on seemingly impossible edges. While we can't truly defy gravity, it's fascinating to explore the different ways we can seem to. Remember, science is all about questioning and exploring the world around us. Until next time, keep exploring.